Hi, everyone. Just a quick note, we will have a small interactive thing in the middle, so whoever wants to participate in that, it's going to be on your phones. If you can be connected to a Wi-Fi network, that would be great. If not, it's no problem if you don't want to take part in it. Cool, so Altan, it's happening. We're here, everybody's here. So are you ready to demo your app for today?
It looks like we're almost ready, but there's still a little bit left. I don't think they'll mind, though. We can just delay.
Oh, goddamn. OK, yeah, I guess we can just skip lunch if it takes too long, but we can just wait on it to finish. Can we go a bit slower? Altan wrote an app and it bloomed. Its success resoundingly boomed. But then he noticed the CI servers fumed, and then his face slowly gloomed. He opened his editor, and through the night he gloomed. But the deadline slowly loomed, and the build times just zoomed. And he slowly realized that it could all be doomed. Unless he'd start taking CI scalability more seriously. And although piano music doesn't start on cue in real life all the time, a lot of teams do go through similar problems.
Hi, everyone. I'm Altan, and this is Rareş. And we didn't really know that there were going to be two projectors. But what we do know is this is a regular problem for many workspaces. And so we're going to tell you today how NxCloud can help you solve that.
Cool. So as new developers start joining your startup, they might be assigned to different teams. So some teams might need to build customers-facing front-end apps, maybe some GraphQL APIs, and even some C#. Oh, and the mic. Cool. I'll use this one. I'll just. OK, cool.
We planned for this.
There was some popping in the mic. So because of the problems with shared publish package versioning or sharing code, you decide to put everything in a monorepo. So because now it's going to become super easy to start coordinating on shared code, you're going to have all these libraries appearing, and all these relationships between them are going to start to form.
Now, monorepos already help with your CI setup because you can create one folder and put your whole pipeline in it. Now, since all of your code is co-located, you can use a series of imperative steps to kind of define a single project and a single target one by one. This might be something that you're used to. Now, this can be good news because you don't need separate Circle CI accounts or whatever provider you're using, and all of your processes can be standardized in a simple place. But because these CI configs are usually written as a set of imperative steps that refer to these specific apps, they have to be constantly maintained as your workspace grows or changes or anything in between. Now, as time passes, you'll have more and more libraries appearing that need testing or linting or building. And if you'll stick with me for a second while we use a literal pipeline here, all of these small tasks will eventually start to clog everything up. Now, your existing apps will also start growing, requiring more code, and those will slow down. Not to mention adding features that need to be end-to-end tested, and it's just going to clog everything up even more.
So on day one, it's simply impossible to predict what problems you're going to have on day 300. Your teams will simply be making too many decisions to know how your pipelines will need to evolve in their configurations. So will my team start placing more value on end-to-end tests? Well, maybe that's going to slow down the pipelines. I might need to go back to them and refactor things out. And those 50-minute build times, they're slowly going to creep up on you. Right? They're slowly going to become the new normal that your team has to get used to. And by the time they become so slow, nobody's going to want to touch them for fear of breaking something. But there's something we can do. So one measure we can take is to just put less stuff in the pipeline. So if I only change those two libraries there, I should only have to lint, test, and build those two libraries and everything they could possibly affect above them. So that should reduce the amount of tasks that need to flow through your pipelines, right? And it should smooth things out a bit. And we've all used NxAffected, right? I'm not going to focus too much on it. But what I do want to point out is the declarative nature of this config. So we're letting another tool make all the granular decisions about what should happen on each CI run. Declarative configs such as this one is how you scale and you keep your CI configs simple. And NX has this cache folder. Right? So as you're running commands inside your workspace, it's going to look at what commands you're running against which source code, and it's going to keep building up this internal memory of hashes that it can use to quickly replay commands for you in the future. But there's so much more to caching. If I run NX affected, if I run the affected end-to-end test, well, NX is going to break that down into all the affected apps based on what's been affected. And because I configured and because I told NX in my NxJSON config that before I build any project, it must ensure that all of its buildable dependencies are built first, right? So that little hat there means dependencies. And because I configure my end-to-end test to just serve the build assets from dist directly, rather than serve them into memory each time, I basically separated the end-to-end target from the build, so I'm having it delegate instead. Then NX is going to make sure to orchestrate everything properly. So before it runs the end-to-end test for my pizza app, it's going to make sure that the assets for the pizza app are inside this, and if they're not, it's going to actually run the build. And before running the build for the pizza app, it's going to make sure to run the build for the shared component. And same for the admin app. It's going to make sure to build the admin app and build the shared library. And because this Cypress test for my storybook shared components just need the shared components built, it just needs to run that. And then it's going to sort everything topologically in the order they're needed, and it's going to make sure no task is executed twice. But check this out. Because I built my pizza app up there, it can just retrieve it from the cache in that inner task in there. And because when I built the pizza app initially, I had to build the shared UI library, well, the cache is already populated with the assets for that. So it can just retrieve them when the time comes to need that library inside those inner tasks. So it's surprising how useful caching can be if you split up your libraries well and you configure the dependencies between your tasks. So if we take that cache folder and we move it up into the cloud so it's shared with your whole team and your whole organization, well, if you imagine your workspace as a series of blocks, as different developers and different PRs appear, they're going to be needing to build different sections of your graph. And these sections might start to intersect, right? So anytime they intersect, they can just pull each other's results from the shared cache, like we did with the shared UI library in there. So that's why if you have a library in a very hot path in your graph, like it is in there, that everyone's going to intersect with, you can explore making it into a buildable library, right? So that the computation for building it can be shared with everyone else in your team. So do explore splitting up your tasks and defining relationships between them. You can split up your tasks by making some libraries buildable, or having end-to-end tests delegate the build to another process. You can use module federation to split up huge builds. Similar, smaller tasks and libraries and well-defined relationships between them enable caching, and as we'll see later, distribution to work really well. And another example is CI is constantly running on each commit that goes into your main branch. So it's consistently keeping the cache warm and ready for everyone else to use. So if I change just that one library there, and I affect this section of the graph up above it, well, CI will obviously need to run the lint task to verify that my change is past linting, right? But because by changing the source code of a library, I can't really affect the lint results of its parents, we can just pull the lint results for all of those libraries above it from the shared cache that CI has been keeping warm for us. So how does that work, right? Because if we change a library, we'd expect to bust the cache for its parents as well, right? So this is a newish option in newer versions of NX. So in your target defaults in NxJSON, you can not only configure dependencies between tasks, but you can also configure how caching works for each one of your targets. I'm not going to go too much into detail because this is a bit advanced, but hopefully if I mention it, I'll make you a bit curious, and then maybe you can read more about it after the talk. But for linting, for example, I can say that the lint results for a library depends only on changes to the files inside that library and changes to the root ESLintRC JSON file where we have all the main rules that apply to the workspace, and nothing else. So if I now change a library, I can just pull all of its parents from the cache. Right, so in files in the library and the root file.
Hello?
What else do I want to talk about?
Rareş, is this a bad time? My niece needs help with her math homework.
Your niece needs help with the math homework.
They've got the collaborative link, so it's going to show up on the slides.
Oh, God. Okay. Well, let's do it. Yeah, it's not a bad time. Let's do it. Let's do math.
All right.
Good. Okay, hit me. I can do it.
What is 90 plus 11?
101.
All right, looks like that one's right. What's 167 plus 51?
210, 218.
Okay, perfect. What's 258 plus 99?
357.
Okay, I think there shouldn't be too many more. 330 plus 79.
409.
Okay, one more. 457 plus 25.
482?
Yep, okay.
Yes.
Oh, man. They just sent me a bigger list. I think we're going to need to call in some help here.
Right, so I'm not the best person to be doing these either way, right? So I'm sleep deprived, I'm bad at math, but even the smartest person in the world, if you were to give them math exercises, there's only so many exercises they can do per second, right? We are limited by, so even this applies to your CI as well, your CI agents, there's only so many tasks they can run at any given time. We are simply, we cannot get around the fundamental laws of physics imposed on a single machine's hardware, be it carbon or silicon based. So do we have any more to do? Or?
We do.
Oh.
We do. There's quite a few. 100 math problems.
You know, I don't think we have time. Should we have some distributed power in the room, right? Should we try and get some help with this?
Yeah, I think we should. All right, so while Rareş is changing out the slides here, if everybody can get out their devices, if you're watching online, you can take part in this too. You can either scan this QR code or go to nxmath.netlify.app. What's going to happen is we're going to use all of you to solve these problems as fast as possible. We really appreciate it if you get in there. You're going to be assigned a problem randomly, and when you complete it, you're going to see it marked as complete on this screen. So we'll give everybody about 15 seconds to get this up. If you're online, you'll be good to go.
So you don't need to enter a nickname. Even if you start later, it takes a while for you to get set up. It's okay. Like, even if we start this, you can still join in later. So you're all going to get pushed math problems. So yeah, anyone who's online as well, they can participate.
All right.
So should we?
Let's do it.
Try and go. And if this doesn't work, by the way, it took me a few hours to make this up. I made it on the plane. So if it doesn't work, we have some backup slides. But cool. Are you all seeing math problems? Game not start. Okay, let me try and reset. Is it on? No.
Yes, it's loading.
How is it loading? Cool. Let me try something else. You can put a random answer. Am I connected? Okay. We'll just give it one more try. If not, I'll activate the backup slides. Okay. So, cool. I did a reset.
All right.
Are you seeing it?
Yes.
Nice.
All right, let's answer some math, everybody's favorite task.
Okay.
There they go.
Oh, see, so you're already helping. Oh, it's getting populated. Oh, I do.
Only a few more.
Oh my God.
Whoever Yo is, you're getting our fancy prize.
Cool.
All right.
And we're done. So you have all the top players there. Congrats to the top 5 players. I don't know who Yo is, but
Truly beautiful.
So let me start the slides again. So we all solved 100 math problems in probably less time than it took me to solve 5. Distribution works. Distribution works. Let me try. It's the microphone. So how do we distribute? Well, if the task graph is flat, that means that if you're lucky enough to have a flat task graph, that means that no task can depends on any other task. Right? So that way we can say maybe, for example, on one agent it does the affected build, on another agent it does the affected lint tasks. But that's not ideal, because then you have this one agent doing work for all this time, and this other agent just idling away. So you can try to be smarter about it. You can try to maybe distribute them a bit more smartly, but that's going to require constant manual intervention and rebalancing. And that's not even the biggest problem. Most task graphs are like that, where you have some end-to-end tests that depend on the build of an app that depends on the build of its child libraries. In that case, we're going to have to run all of those tasks on the same agent so that they have access to each other's outputs on that agent's file system. We just saw how good NX is at orchestrating tasks for you locally based on some declarative configuration. What if we let it orchestrate distribution as well? I can declare this top-level CI YAML file where I just tell NX what I want to happen on each pull request run. And then if we have 3 agents, for example, in this example, I'll just let the central distribution service orchestrator handle the distribution for us. So it's going to start pushing tasks to each of the agents, same as you've been getting tasks on your phone in the previous exercise. So maybe this agent will get some lint tasks in the build. This other agent will get some build tasks and maybe some tests. And this third agent, well, they might get some tests and maybe some lint tasks. And when the time comes, end-to-end tests will just be distributed again amongst all the agents. Right? So NX knows from historical runs how long each task takes, so it's going to make sure everything is perfectly balanced. But have a look at this. This agent just ran some tests and some lint tasks. And then it needs to run some end-to-end tests that actually need the build of an app. But no build happened on this agent. The build that it needs actually happened on this other agent. Well, distributed caching doesn't just make your commands look instant. It's also an enabler of distributed execution. So with distributed caching, we can just move computations between agents. And we do not have to do this imperatively anywhere. We do not have to manually define that the build needs to run before those end-to-end tests on that agent. This is the power of declarative conflicts such as this one. With just a few lines of code, we enable all this automated distributed orchestration. So we are not limited by how tasks depend on each other anymore when deciding how to distribute. So now we have this dial, where if CI gets too slow, we can just add more agents and it's going to get faster. If it gets too expensive, we can just dial it down a bit and reduce the number of agents. And NX will make sure that all the tasks are perfectly distributed. Ah, I can see your build's finished, Altan. So
Finally. All right, so now we've talked about what distributed task execution can do for you, but I'm sure that there's a little bit of reservation about setting this up, right? It must be complicated. But fortunately, we have first-party tools that should make this a lot more simple for you. Today, we're going to be working with my NX Casserole, which has a ton of different web frameworks in it. We've got Astra, we've got Solid, Next.js, Nest.js, Angular, Pure Node, and Svelte, the full gamut of the web frameworks. All of this can be distributed with NX. You heard me right. All of it can be distributed with NX. In fact, any language, framework, or tool can be distributed with NX as long as it's marked cacheable. But if you're a Lerna user, don't turn away yet, because from Lerna 5 and Lerna 6, you get all of these same benefits. Now, the projects that we're working with today are fairly straightforward. They're just pulled right out of their generators. So we have normal target names, things like build, or lint, or test, or even E2E. But if you have custom targets, you just need to make sure that those can be marked as cacheable and add them to this property. How do you know if something can be marked cacheable? Well, does it provide a consistent output given the same set of inputs? If it is, you're probably safe to mark it as cacheable. Now, like I said, there are some tools that make it easier for us to set this up. So we're going to install the @narwhal/workspace package. Why? This contains a generator that's going to make it considerably easier for us to get our config started. Now, we just need to hope that the Wi-Fi in here isn't flaky. No, I'm just kidding. We all sit through enough NPM installs. Now, to really get this going, though, we're going to run npx nxg for generate @narwhal/workspace:/CI workflow. And this is going to help us get started. We're going to use GitHub Actions today. And we don't really care about what our workflow is called, so we're just going to go with the default, CI. we can see that we've created a file here in the .github/workflows folder, ci.yaml. So let's take a look at what was generated for us. This is all we need to enable distribution. It's under 30 lines, and it fits on a PowerPoint slide. But not everybody here is going to be familiar with GitHub Actions, so let's go over what's in this file. We've got our name. The name is a user-specified identifier. It doesn't matter what we call this. We could name our pipeline Carl. It would work the same way. Distributed task execution is not impacted. The next thing we have is on. On is going to tell GitHub when we want this to run. By default, we're going to use the main branch every time it's pushed to, or on any pull request. But if your organization uses a different name for its primary branch, just change that out. That won't impact functionality either. The bulk of the magic occurs in this jobs property. So we have two child keys here, you can see, main and agents. Both of these are using reusable workflows that you can find at github.com/narwhal/ci. And there are kind of two big things to think about here. The main job we like to call the orchestrator. You can think of it like the brains, right? It's responsible for sending your commands up to the cloud, breaking them into pieces, and waiting for the results. On the other side, we have agents, right? Agents are more like the brawn, the muscle of our workflow. And they're just going to pull for work constantly until there's no work left, and then they'll turn off. When we talk about configuring main, this is all the more we have to deal with. So we've got a couple properties in here. Number of agents should be fairly self-explanatory. This is going to tell us how many agents we want. This can be useful if you want to spin up a larger amount. It improves our heuristics for your scheduling, and it's just a good thing to know. Init commands, this is where we want to do any additional setup that might not be contained in your Docker image that you're using to run your pipeline. So by default, we have NxCloud start CI run here. This is a useful utility for us. You can see there's an argument on there, stop agents after. What this means is after all of our build tasks are done, if there are any idle agents, they'll be shut down. Now, this is immensely useful for when you start to have larger workflows, especially when you're using a platform that builds off of utilization. You don't just want to have your agents running and doing nothing. If you have any other global utilities you might want to set up here, you can also do that here. We have parallel commands. This is parallel on a single machine. So when we're talking about our orchestrator job, we're going to be running lint and formatting here. You can think of this like using the Unix AND operator. And finally, we have the distributed part. So parallel commands on agents will take the tasks that we have listed here in a declarative way, like Raresh has mentioned, and it's going to send them up to the cloud slowly to be processed by our agents. Once that's all good, we'll sit here and we'll wait for results. What about configuring our agents? Well, that's considerably more simple. Because we're using the reusable workflow, the only thing that we have to provide is a number, right? So if we have 3 agents here, and that means we're going to spawn 3 agents. With this small amount of config, we're able to achieve this flow, where our orchestrator will send tasks off to NxCloud, they'll be processed by our agents, and all of the output is sent back to our main job. Now, this is immensely powerful, because from the perspective of your main job, all of the computation is just like it's occurring right there. So if you have code coverage reports that you need to combine, it's right there for you. You want to do a deployment step off to your provider of choice, your artifacts are all there for you. But what about in 6 months? Like we talked about at the beginning, when your project has started to scale, you might have more employees, and your builds are slowing down. Simply turn the dial and add more agents. When we're using NX with distributed task execution and the power of affected, this is all the more we need to scale our pipelines to keep our developers working smoothly. Now, there's not to say that there's not more things to think about with distributed task execution. There is a balancing act involved here. There are 2 big things to think about: our agent utilization and the raw number that we have. Now, our agent utilization we're going to define as over the whole runtime of our pipeline. Out of that, how long was our agent used? And the agent count is obvious. So if we go for a higher agent utilization, like Raresh talked about, this will be cheaper because we don't have as many agents running in the first place, but it might result in a slightly slower pipeline. That's something that you can work with your development team on to figure out if they find acceptable. On the other hand, if you have infinity money to spend, you can spin up 10,000 agents. Distributed task execution will work correctly, and you might just pay for a lot of idle time, but you'll be getting the fastest pipelines possible. Most people will try and settle for a perfectly balanced approach where you're in a hybrid of between cost and performance. But how do we know what our utilization is looking like? Well, the easiest way to do that is using our GitHub integration. When you've put in a PR, you can see a link to all of the runs for a certain branch, and if we were to follow that, you're presented with this beautiful graph. So this was 10 agents running on the NX casserole, and we can see that over 50% of them had under 50% utilization. This means that we were burning money for half of the time for those agents. If we drop this number down to 6, we can see that now the lowest agent utilization we have is 70%. We've made a huge improvement, and this is a 37% cost savings against 10 agents. Now, what about in literal time? How does this play an impact? So for our different options here, we can see that with 10 agents, our whole pipeline install and running only took 4 minutes and 17 seconds. But with the cost savings that we talked about for 6 agents, we've only added 40 seconds. So there is a bit of trial and error here. We can't prescribe how many agents you're going to need. If we wanted to go even cheaper, we can see that we do start to get diminishing returns on reducing our agent count, and we've bumped up our time an additional 2 minutes from here. So with that in mind, what's stopping you from trying DTE? We've already told you it'll make your pipelines faster, it's easy to configure, and it'll scale, not to mention that NxCloud is free for most workspaces.
Okay, so in summary, here are some things you can do to help you scale your workspace and prepare it for scaling in the future. You can favor and build hands-off declarative CI configurations that will hand off scaling decisions to an automated tool such as Nx. Enable distributed caching and add your named inputs to improve that cache hit ratio for your tests, builds, and lint tasks, and even E2E. Enable distributed task execution, and explore breaking up your tasks into smaller units. So if your workspace is a bit more granular, and if your tasks are a bit more split up, and they have, like, their dependencies are configured between them, the more caching and distributed execution can help you. So thanks a lot, everyone.
Thank you.